The Linode Kubernetes Engine. It just reached general availability, and I decided that it'd be fun to go ahead and check it out and do a video on it. Now, Linode is a sponsor of my channel, but actually I wanted to check this out for my own devious purposes because any opportunity I can get to try a new implementation of Kubernetes, I'm definitely going to try it out because, well, Kubernetes is fun and I love it. So what I'm going to do in this video is show you guys how this new Kubernetes engine works, and then I'll walk you through the process of deploying a container. It's going to be a lot of fun, so let's go ahead and dive right in. So here we are on the Linode dashboard, and I'm itching to get started, but before I do, there's a few disclaimers I want to get out of the way first. Now, first of all, the services and resources that we create through this service will incur a cost. However, I do have a special link in the description below if you don't already have an account with Linode that'll get you some credit to get you started. In fact, normally in my videos, the special link I have through Linode will give you $20 in free credit, but for a limited time, you can actually get $60 in credit to make sure that you have enough balance in your account to handle all the worker nodes that you'll likely create as you try this out. And considering that they charge basically hourly, then you really shouldn't incur any costs at all. What I would do is go ahead and delete the resources that you create as soon as you're finished with this video, unless you do actually want to keep this around. It's a really awesome service. Maybe you might have some apps that you want to run in a Kubernetes cluster. If that's you, then definitely keep that going. I just want you guys to be aware of the fact that this will incur charges if you leave these resources running. Now, with that out of the way, I'm logged into my demo account right now. You can see that it's basically completely empty. And on the left-hand side, we have an option here that is called, simply enough, Kubernetes. So if you click on that, it's going to give you an option to create a cluster if you don't already have one. So I was trying this out off camera, and then I went ahead and deleted everything so you guys would see what it's like to start from scratch. So what I'm going to do is create a cluster, and I'm going to call it LLTV test cluster. Clever, I know. For the region, I don't really have a preference. Canada is pretty cool, so I guess I'll go ahead and select that. And then you can go ahead and select your Kubernetes version. I'm going to select 1.17 for mine. Now, when you scroll down, we get a chance to create our worker nodes, basically Linodes that will be handling our workload. And you can go ahead and select them accordingly. Now, in my case, I'm going to create one Linode that is 2 gigabytes right here. I'll create more in just a moment because I know a Kubernetes cluster with just one worker node is probably unusual. But then again, if you're only running 1 or 2 apps, that's probably fine. So I'll click on the Add button here. And then on the right, we can see that the cost went from $0 a month to $10 a month. And that's where you can go to basically understand how much this Kubernetes cluster is going to run you each month. So that's pretty easy. And right here, it's recommending at least 3 nodes, which I'll go ahead and correct that in just a moment. But as far as this page is concerned, there shouldn't be any more information that I will need to provide to get this created. Now, one thing I do want to point you guys to the existence of is this documentation link right here. If I click on that, it's going to bring you to this awesome page that is going to give you even more information about LKE, basically the Linode Kubernetes Engine. So definitely bookmark that if this is something that interests you. But anyway, let's go ahead and create the cluster. Now, the cluster is actually being created right now. It gives us the endpoint, and it will give us our kubectl file as soon as that's available. So basically, we're just waiting for that to generate, and then we should be good to go. Now, we can see here that we have one worker node that is currently provisioning. And it did recommend that we have no fewer than 3. So what I wanted to do is show you guys that you can resize the pool at any time. So I'll click on that right here. And what I'm going to do is just add a few more, and then save the changes. And that's pretty easy. You could basically resize the pool whenever you'd like, and it automatically handles adding those worker nodes to your cluster, and that is awesome. So as you can see here, all 3 of my worker nodes are ready to go. And the kubeconfig file right here is also ready to go. I'm going to go ahead and download that, and I'll save it. Now this YAML file is protected. You're definitely going to want to keep that safe, because if that file falls into the wrong hands, they'll be able to actually manage your cluster. So definitely don't show that file in the clear. Don't send it to anyone unprotected. And certainly don't show it in a YouTube video that thousands of people are going to watch. So what I'm going to do is do exactly that. I'm going to bring up a text editor here, and then I'm going to go ahead and open the file. Go to my downloads directory, and here's that file. And you can see that it does have some very confidential information. It has your certificate authority data for your cluster. It also has your token. So basically, whoever has this file has basically enabled God mode, and they can do whatever they want. Now, the reason why I don't care that I show this in front of all of you guys, because, well, it's just a demo account anyway, and I'm going to go ahead and delete everything once I'm done. And I thought it'd be cool for you guys to actually see what it looks like in practice. So I'm going to go ahead and close that. And what we're going to want to do is download the kubectl application so that we can actually interact with our cluster and manage it. I'm going to switch down here to a terminal. And let's go ahead and get started on actually managing the cluster that we just set up. Now, on my end, I don't know which Linux distribution you are running on your hardware. So what I'm going to do is paste in a command right here that's going to work regardless of which distribution you are running. So go ahead and paste that in there. And basically what we're doing is we're just running the curl command to download the kubectl application. So if I press enter, that was pretty quick. And if I list my storage, you can see that I do have kubectl downloaded right here. And you can also see that I have some additional files here as well. So I have several example YAML files that I'm going to use to show you guys how this works. I also have my notes as well, because, you know, I got to keep track of things as well. So what we're going to do is go ahead and mark that executable. So it's chmod +x on that kubectl application that we just downloaded. And it's not installed locally, as you can see, which kubectl gives me nothing, even though it is in my working directory, and now it is executable as well. Now for security purposes, what I recommend that you do is go ahead and change the permissions of kubectl. So what I'm going to do is sudo chown root:root against that kubectl file. So now we can see that it is owned by root. So you have to have root permission to change the file, which gives us an additional layer of security. So what I'm going to do is sudo move, or mv, and I'm going to move kubectl into user local bin. And that's a very general directory if you want something to be available on the shell regardless of where your working directory is. Now, honestly, there's other folders you can put that in. I'm not going to get into that. But if we do which kubectl, just like that, we can see that it is found. And if we enter that command, it's not going to do a whole lot here because we need to actually give it some instruction. But we do get a little cheat sheet here if we enter the kubectl command with no options. And this cheat sheet is great because it gives you basically, well, all the options. So if you want to know more about what this utility can do beyond what I show you in this video, then that's an easy way to get to that information. So next, what I'm going to do is show you this command. I'm just going to paste it in here. What we need to do is basically set a shell variable, in our case, kubeconfig, and we need to set it equal to the path to the downloaded YAML file. So unless you named your cluster exactly the same as me, then this is probably different. So you'll want to adjust this to have the path and the file name for the YAML file that you downloaded. So if I press enter here, that variable is now available. So echo kubectl, and we can see that it is exactly equal to what we set it to. So that works out just fine. So with that out of the way, we should actually be able to use the Linode Kubernetes Engine. Now, obviously, we don't have any pods, but we should be able to do this, kubectl get pods, and there's no resources found in the default namespace, which means, well, we don't have any. So what exactly did this do? Now, you notice we didn't give it an endpoint or anything. Actually, everything we need is in that YAML file. And since we created that variable to store where the kubeconfig file is, then we've gone ahead and satisfied all the requirements that kubectl needs to contact Linode and help us manage our cluster. Now, if you recall, I have my kubeconfig file, again, this one right here, in my downloads directory. That's probably not the best place to put it. I would recommend putting this somewhere else, preferably a directory that is readable only by your user, somewhere safe, and then you can go ahead and recreate this variable with that path. Because downloads, I mean, it's probably not a good final location for that file. But I'll leave that up to you. We know that everything is working because, again, we were able to do kubectl get pods, and that worked just fine. So now we have a cluster that's all set and ready to go, and we can also interact with it by using the kubectl command. So what I'm going to do right now is show you guys the process of deploying a container to our cluster. So in this directory, I have several files, and what I'm going to do is show you this file right here. This is the first of my examples, and I'm going to open that up in a text editor here and show you guys what that looks like. And here it is right here. This is very basic. Now we are deploying an app called The Lounge. And what The Lounge is, it's basically an IRC server that you can run to host your IRC sessions. So you could keep your IRC sessions basically independent of which computer you happen to be using, because you're basically creating an IRC server that you can access from whatever computer you are using that will have all of your chat history and everything like that. So what we're doing is we're running the Lounge right here. Like I mentioned, it's a container, obviously, because that's what we run in Kubernetes, containers. And the name is the Lounge, but the actual image is Linux server / the Lounge. And you can get the Lounge from other resources and other registries. Linux server is one that I like a lot because they even offer ARM, and that's great because I also have a video on my channel that shows you guys how to create your own Kubernetes cluster on ARM. And that's why I like this Linux server registry right here, because again, I've been able to find a lot of containers there that support ARM. Now obviously that's not a concern here because this is Linode and this is x86, which means that you're going to have basically the ability to run a lot more containers because almost everything supports x86, let's face it. But I basically wanted to let you know that we're running a container called the Lounge, and it comes from this registry right here. Now that particular container runs the server on port 9000, and I'm going to give that container port a name of IRC HTTP. That's pretty self-explanatory. Now of course we have API version 1. We're not going to change that. We're going to leave that alone. The kind is a pod, and we do have the ability to set some metadata in our YAML file. So I'm basically just going to call this application the Lounge, and I'm going to give it a label of IRC. Now this isn't really going to come into play right now, but I will talk a little bit more about that shortly. So let's go ahead and get this running. So what I'm going to do is run kubectl apply-f, and then the file name that I want to apply, which is this one right here. And that's it. We're done. We just successfully deployed a container to our cluster. It was literally that easy. Now, I will have a wiki article in the description below this video where you can go and get all of these files and commands that I've used in this video in case you've missed anything. But let's go ahead and check on that pod, shall we? kubectl get pods. It's already running. So what I'm going to do is destroy it. Delete pod the lounge. So I showed you the command to create a pod, and now I'm going to show you the command to delete a pod. To delete it, kubectl delete pod, and then the name of the pod we want to delete, easy enough. And it is typical for the command prompt to hang a bit there as it deletes the thing that you told it to delete. It's just making sure that it actually is deleted. So if we run get pods again, it's gone. Now what I'm going to do now is go ahead and apply this again, and then get pods. And it's already running. What I was hoping would happen is that I would go ahead and show you the process where it's not ready and you've got to kind of wait a little bit. I didn't expect it to be quite this fast, but it makes sense because the container is already downloaded on my worker nodes and all it needed to do is just recreate itself again. Now the problem with this is that we can't actually access this in any way, shape, or form. Yes, it is running, but by default, if you run a container in a Kubernetes cluster, it is not accessible from outside the network. Now we could get a little bit more information here if we run kubectl describe pod, and then the name, of course, which is the lounge. With kubectl, we have get and we have describe. Get will tell you just enough information. Describe is going to give you a ton of information. So I want to get some information on the lounge, on this pod in its current running state. And look at that, we get a bunch of information here. So if I scroll up, we can see the app label that I gave it in the YAML file, and also the name as well, the lounge, just like I said it. And we get the IP address right here. We also get the port number of 9000. But we're not going to be able to do anything with that like I mentioned. So if I was to go ahead and copy this IP address right here, and then go down here to a web browser, paste the IP and the port, obviously that's going to do absolutely nothing. Because again, these containers are not publicly routable at all by default. We will take care of that shortly. And some more information that we get here, we can see when the actual container was started. So I'm recording this on the 9th of June, as you can see. Its state is running, so there are no actual problems with this right now. So even if we were able to access this IP externally, it's not doing any port mapping, so that port isn't even being exposed. And then finally down here, we have some information about events that are related to the container that we're running. Now, what I'm going to do is show you guys how to expose this container externally so that we can go ahead and access it. So again, here are the files that I have. And I have a file right here called load balancer. And that's the one that we're going to apply. But before I do, let's take a look at it. Now here we have a kind of service. The previous one was a pod. We have some metadata. Again, we're going to name it the lounge. That's the name of the application we're running. We also have an annotation right here. And what this is going to do is tap into the Kubernetes service for load balancing. And Kubernetes actually knows what a load balancer actually is. And what that does is that actually taps into the platform that you're using to go ahead and start a load balancer. Now, depending on what platform you're using, load balancer can mean something different. So for example, if you are running on Google Cloud, then that is a different type of thing than if you are running on AWS. But load balancer is a load balancer that's going to tap into the platform that you're running on. And in our case, we are running on Linode. So it knows that Linode's implementation of this is a node balancer. There's more to it than that actually, but we're just going to simplify it to that for now. And what this is going to do again is allow us to be able to access this externally. Specifically, what we're going to do is we are going to expose port 80. I just figured that would be easy enough. but it's going to target that to the IRC HTTP port. If you recall, the default port for the lounge is port 9000, and in the YAML file for the pod, I gave that port the name IRC-HTTP, so that has to match. We also have a selector right here, and if you recall, we set this key named app to IRC in our pod file, and this is how the load balancer knows which container to send you to when you go to access it. And the concept of load balancing in Kubernetes goes beyond this, but I think that's enough for this video. Let's go ahead and apply it. So kubectl apply-f, and then the YAML file right there. So I'll press enter. And just like we were able to do kubectl get pods, we are also able to do kubectl get service as well. And we can see right here that we have a load balancer right here that's been created for us, and it even gives us an external IP address right there. So if this is working, we actually should be able to access this container right now. So let's go ahead and see. So what I'll do is paste in the IP address right here, and I'm not going to include a port number because if this is working, it should take the default port 80 and automatically map me right over to the appropriate port on the container. So let's give it a shot. And what do you know? We have the lounge right here. We are running this in a container, so we have successfully not only deployed a container, but also a service that allows us to actually use that container. And now we can use the lounge to go ahead and connect to our favorite IRC channels and start chatting. Now, let's take this one step further because we still have a problem. It's great and all that we can access our app right now, but if we delete the container, any persistent data is gone. Docker containers, which is what Kubernetes runs by default, store no information. So as soon as you delete a container, everything that's related to that container in terms of data and persistent information is wiped out. So what I'm going to do right now is walk you guys through the concept of actually creating persistent storage for our container. Now, first of all, what I'm going to do is basically tear everything down. So here we have our service. We don't want to delete this one right here, but I will be deleting the one that we just created. So kubectl, you probably can guess what I'm going to type next. Delete service, the lounge, and then enter. And it went ahead and deleted that, or so it says. And sure enough, it did. Kubectl get pods. We see the lounge is still running, obviously. And we shouldn't be able to access it anymore because we deleted the load balancer here. So let's go ahead and try. It should fail, and sure enough it did, because again, we deleted the load balancer, so we have no way to get to the container. So let's go ahead and delete the app. And there we go. It should be gone. And we've wiped everything out. So I have a second version of the pod file, and that's this example file right here. Let's go ahead and edit that file so I can show you guys what that looks like. And right away you can notice some differences. So coincidentally, it brought me right to the line where it is different from the last one. And we can see that we have something called a volume mount. And volume mounts are basically a path on the container that we can map to a volume. So on the container, we have this directory right here, /config, which is going to store, well, our config. And since that directory is inside the container, again, if we delete the container, the contents of that directory are completely wiped out. So since that's where the lounge is storing its data, that's the folder that we're going to want to map to a persistent volume. And we're going to refer to this volume as the lounge PV, short for, of course, persistent volume. And here is where we set our volumes. Again, we have the name, and it's going to be the same right there. And we have something called a persistent volume claim. And the claim name is the lounge PVC, short for, of course, persistent volume claim. So what exactly does that mean? So the concept of persistent storage in Kubernetes is handled in an interesting way. You basically have two things. You have volumes and you have claims. A volume is simply creating a place to store data, and a persistent volume claim is basically saying, hey, I need data. And a persistent volume claim will basically look at the data or metadata surrounding that, maybe the size, things like that, and we'll go ahead and apply that as necessary if there's a match in the requirements to a volume that is available. So to make that make more sense, let's look at another file here. So I'll bring it up. It's this one right here, the lounge PVC. So the persistent volume claim is in its own file here. And this is a simple file right here, not a whole lot to it. The metadata right here is giving this persistent volume claim a name of the lounge PVC. We have our access modes. It's read, write once. Then we allocate our resources. So what I'm saying here is I need a storage volume that is at least 10 gigabytes. And I feel like that's a lot more than we need for this particular container. I mean, it's just storing text for the most part, but 10 gigabytes is the lowest amount of storage that you are able to request. I even tried to put a lower number here, and when they say 10 gigabytes is the minimum, they mean it. I put 5, it changed it to 10, so I'm just going to have it as 10 in the file. Then we have our storage class of Linode block storage, which is what's ultimately going to be created here. So now what I'm going to do is first apply the new pod file. So again, kubectl get pods. We don't have any. So I'm going to recreate the lounge pod with this file. And that's created. So if I do get pods again, it's telling me though the status is pending. Why is the status pending? So let's find out. kubectl describe pod the lounge, because again, we want to get more information on this, find out why is it pending. I already know, and you could probably already guess. So what it's telling me here is persistent volume claim the lounge PVC is not found. So if I was to bring that file back up into a text editor so we can take a look at it, you'll recall that we are basically using a persistent volume claim with this name right here, which is exactly why it's expecting to find it. And we can run kubectl get pvc, and it shows nothing, but that's the command that we would use to list the persistent volume claims that we have. So let's go ahead and get that created then. So kubectl apply -f the lounge PVC, enter. It says it was created. So let's go ahead and check that out then. It created it, it bound it, it should be ready to go. So if we check on our container, now it says container creating. So basically when it says that, you just give it some time. And if you're impatient like me, you just keep pressing the up arrow and then enter over and over again. And we can see that it is now running. Now we also deleted our service as well. So kubectl get service only shows the main Kubernetes. So we need to recreate that so we have a way to actually access this. So we'll do kubectl apply -f, and then we'll reapply that load balancer file. And now we have a load balancer here. We have an IP address. So I'll go ahead and paste it in right here. And there we go. We have the lounge again in our browser. We're able to use it. And we should have persistent data as well. Now when it comes to persistent storage in containers, what you'll want to do is inspect the container and the directories to find all the directories that are important. Maybe there's another directory that is important, maybe a logging directory or something like that. Or maybe when you're watching this video, maybe the lounge container changed, maybe the path is different. So you'll definitely want to inspect it to go ahead and make sure that you are targeting the right directory. But for the purposes of this video, I just showed you an example of creating that persistent volume, so we should be good to go. But when it comes to inspecting the container, let's go ahead and see how exactly we do that. Well, what I want to do right now is show you guys that. And also, I'm going to show you how to configure the lounge, just change a few things basically, so we can see that it is truly persistent storage. It is saving our changes. So I'll paste in the command. And this is, again, using kubectl. We're going to execute something. We're going to execute it against a container of the name the lounge. We have two dashes right here, which are essentially separating the kubectl command from the command that we actually want to execute inside the container. And basically what I'm doing is just using ls against the /config folder to show you guys the contents that it has. And here it is. So we have this file right here, config.js. So what we can do to edit this file is recall this first, and then we could basically run this. We'll use the vi text editor against the config.js file that's within the config folder that our persistent storage is mapped to. And if I press enter, it appears in a text editor here. So first of all, we have this line right here that I don't like, at least not for my use case. I don't want this server to be used by everybody. I want this to be a private server, so I could do append mode here, which basically means you press lowercase a after the last character that you want to edit. So I'll just change this to false and press escape to get out of insert mode. And that should be the only change that we want to make to this particular file. So I'll go ahead and save it, :wq. And next what we want to do is go ahead and enter into a shell on that server. So to do that, that's pretty easy. I'm just going to simply change this to bin bash for the command that we are going to run against the container, which is actually going to give us a command prompt that's actually running from the container. So if I do ls, for example, we could see that we are getting a listing of files inside the container. And of course, we have our config folder right here. So what I'm going to do right now is create a user for myself. So I will do the lounge, which is the command that is recognized inside the container. I'm going to do add, and then the name of the user I want to add. Now it highly discourages running as root, as it should. Now running a rootless container is beyond the scope of this video, so we'll go ahead and ignore that for now, but I'm going to type a super secret password here. Save logs to disk, sure, why not? And what we can see right here, we're going to ignore the warnings because this is just a demo. We have in our config directory, a users directory. Well, we already had that, but now we have a JSON file for my username. And sure enough, if I do an ls against that directory, we can see that we do have that file there. And I'm going to show the contents of that file. We have the password hash and the log option set to true. So now what I'm going to do is have some fun. So I'm going to disconnect. I'll just press Control D. Back to my local command prompt. So kubectl get pods. We have our pod right there. So I'm going to run kubectl delete pod the lounge. Let's go ahead and trash it. And we'll wait for the deletion to finish. And there we go. So we have no pods currently in our namespace. And then naturally, if I refresh this page right here, it's never going to work because we deleted the pod that the load balancer would have been sending us to. So let's go ahead and recreate that. All right, so let's go ahead and check on that. Container creating, still creating. And eventually, it's going to show that it's done. And now it's done. The container is running. So if I refresh this page again, I should be able to log in with the password that I just set. And it worked. How about that? Now we made our container private. We were able to set a user for ourselves. That's pretty cool. But wait a minute, we deleted the container, right? Well, yeah, actually we did. So if I was to go ahead and connect to that container again, so I'll paste that command in right here. We'll do an ls-l against the config directory, but I'm going to go ahead and also append /users there. Let's see what's in that directory. And sure enough, my user is still there, even though we deleted the container, which is the entire point of persistent storage. So now I'm going to show you guys how to tear everything down. Now, obviously, if you want to keep the cluster around, don't do this. And if you want to keep the lounge available, if it's something that you want to use, then you certainly don't want to delete it. But I'm going to show you how to tear everything down so we make sure we clean out our account so we don't use all of that credit for things that are running and not being used. So most of these I've already shown you before in bits and pieces. But if we want to go ahead and delete everything, we can basically delete things in whatever order we want. So kubectl delete pod the lounge. Fair enough. And then we also have a service that we created as well. kubectl delete service the lounge. Done. kubectl get pvc. We had a persistent volume claim. So I'm going to go ahead and delete that as well. And that's deleted. So we also had a persistent volume, but that should be gone as well. PVC deletion can also delete that as well. So we should be cleaned out as far as the persistent volume is concerned. But what I would do is go to the Linode dashboard, go to volumes right here, and just make sure that you don't show any volumes right here and just go ahead and delete them if you're not using them. But you won't be charged for the things that you delete after you delete them. Just a quick sanity check. We have no pods. We have no persistent volumes. We don't have a persistent volume claim either. And we also shouldn't have a service. Well, we do. We have the default Kubernetes service. We're going to leave that alone. We should be good to go. And then up here in the Linode dashboard, if we really want to clean everything out, we can go here to Kubernetes and we can go ahead and delete the entire cluster, which is what I'm going to do right now. And there we go. Everything should be cleaned out. And we show some alerts here, which is basically just showing us everything that we have been doing in our account. And there you go. That was an overview of the Linode Kubernetes Engine. That was a lot of fun. So I really like this so far because Kubernetes is a lot of fun. It's definitely something that I recommend that you guys check out. And it's also something that I will make more videos on if you guys want me to. But if you are just learning Kubernetes, or if you want to actually have a production cluster, this definitely looks like a really great service to use. It's easy to use, and I showed you all the examples to get started. So maybe you can go ahead and find some containers out there that you might want to run, some awesome apps. And then if you do, let me know in the comments down below what you are running. Maybe I can use some inspiration for things that I could be running in one of my clusters as well. So what did you think? Hopefully you liked that video, guys. That was a lot of fun. So I have some awesome content coming very soon. So I will see you in the next video.